Okay, so this video is going to be pretty important and pretty packed full of lots of information. I'm going to go at a quick pace because I know that you can pause the video in between problems and let things sink in. But if it's clicking, I don't want you to have to go slow because I'm talking slow. So feel free to pause, rewind, and go at your own pace. Okay, so this is a radical, aka a root. You can have a square root, which this defaults to a square root. You can have a cube root, a fourth root, an eighth root. I mean, you could have a 132nd root if you wanted to. When it's a square root, you don't ever see a 2 right here. When you don't see a number there, it's just understood that it's a 2, so it, again, defaults to a 2. And the little numbers right there, the 2 that's not written, and the 3 and the 4 and the 8 and the 132, those are called its index. So you know what root you're talking about. To be successful with this lesson, you need to know your squares and your cubes and a couple of your fours. So squares real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. That's as high as your brain needs to go. Cubes, 1, 2, 3, 4, 5, and 6, and fours. I have to think about these. 1, 2, 3. That's as high as your brain needs to go. I think 4 to the 4th is 256, but I'm not sure. 2 things I want to point out. Let's see, 16 is a square and a fourth. 64 is a cube and a square. And 81 is a square and a fourth. And in case you didn't notice, 1 is everything. I think those are all my double dippers. Okay. Let's not do that. So, okay. So when I teach this lesson, I talk about going hunting. And when you go hunting, there are certain seasons. And I'm very ignorant with this. I'm not a hunter. But I know that there are different seasons. I know there's turkey season, and there's, dove season and bear season. And so when you're talking about these indexes, these different types of roots, I want you to think about that's the season that you're in. So if it's turkey season and you see a duck, I'm assuming you're not supposed to shoot it. You're only supposed to shoot turkeys. If you follow all the rules, then you should only shoot what's in season. So when I see all these square roots, which everything right now on the screen, let's see, is a square root except for this guy. He's a cube root, and he's a cube root. Okay, so I do have some cube roots in here. There they are. This guy. Okay, so those are my cube roots. Everything else is a square root. Okay, so when I'm in a square root problem, I am only hunting these numbers because those are the only numbers I can shoot. And when you shoot those numbers, you square root them. Okay, when it's cube season and you see one of these numbers in there, you're going to shoot that number, you're going to cube root it. Then whatever number is left is what stays under the root. Okay, well, we all know the square root of 25 is 5, and we all know the square root of 64 is 8, and the square root of 1 is 1. Okay, easy. The cube root of 27 is a cube, so that's a 3. The cube root of 64 is a 4. Be careful there not to put an 8. Okay, so number 6 and number 7 are kind of here side by side for a very good reason. The square root of negative 16 does not exist. The reason it does not exist is I can do 4 times 4 and get a 16, and I can do -4 times -4, and I'll get a positive 16. But in no way can I multiply two numbers that are the same and get a -16. So you cannot square root a negative number. And then later you learned that the square root of -1 is now defined as I. So once you learn that, when you do number 6, you can tell me that the square root of -16 is 4I, because you look at this as a -1 times a 16. Now on number 7, I don't need an I because I can odd root a negative. So 216 is on my cubes, and that's 6. And so the answer here is going to be -6, and here's why. -6 times -6 times -6 is a -216. So negative numbers you can odd root, but negative numbers, when you even root them, that's when the I's pop out. Okay, so 1 through 7 were super kind of obvious because they were in plain sight. Like the deer just comes right up to you and says, "Look at me," and you shoot it. But number 8, it's hiding a little bit. So it's a square root, so I'm in square season, so I'm looking here. 20 is not on my list of squares, so I cannot shoot the 20, but 20 has a square in it. 4 goes into 20, so what I'm going to do is I'm going to break 20 down to 4 times 5. I'm going to circle the 4 because that's what I'm shooting, because that's the square. When I shoot that 4, it becomes a 2, so 2 comes out, and the 5 stays up under the root. Because it's not a square, I couldn't shoot it. 32. 32 is tricky. A lot of people will do 4 times 8 and circle the 4, but 8 still has a square in it. So this leftover number needs to not have any squares in it, so we have to go bigger than that. And 32, I can go 16 times 2, and the square root of 16 is 4, and the 2 stays under. So hopefully you're starting to get a feel for looking for those squares and square rooting them and popping them out, and then whatever you didn't circle is left over. 8 is not a square, but it has a 4 times a 2 in it. Circle the 4, square root that, that'd be 2 with the 2 underneath. Okay, so now we get to number 11. Now we're changing seasons. We are no longer hunting squares. We are now hunting cubes. So the only numbers I care about are these cubes right here. So I need to figure out which one of those cubes goes into 54, and it's 27. 27 times 2, I'm going to circle the 27. The cubed root of 27 is 3, and the 2 stays in. Number 12, a lot of people put the answer is 4, but that's the square root of 16, and I'm hunting for cubes. So I'm going to make 16 8 times 2. I'm going to cube root the 8. And then a lot of people say, well, does it matter if I forget to put my index? No, it doesn't matter. Like, I don't think anybody would count off. But you are kind of changing the context of the problem. You're changing a cube root to a square root. So I would really, really try to form good habits and not lose that index. Okay, X's are so much easier because all you do is divide the power that you have by your index. So here my index is a 2. So I'm going to go 2 into 2, and that goes 1 time with none left over. So that's it. The square root of x squared is x, which you probably already knew. But this one, if I'm doing the square root of x cubed, just take your index and divide it into the 6, and you're going to get a 3. And x to the 6 is the square because it's x cubed times x cubed. So that makes sense. And for this one, again, I'm just dividing my powers by my index. So x to the 5th, y to the 4th. Now, number 16 is different because when I divide it by 2, it doesn't go evenly. So I'm going to have some left over. So here we go. 2 goes into 5 2 times with 1 left over. So if I did, I'm going to come up here. If I did the square root of x to the 11th, 2, which is my index, goes into 11 5 times, goes all the way up to 10. So there's 1 left over. And just, a little side note, anytime you divide by 2, it's either going to go evenly or there's going to be 1 left over. Okay, so for 17, we're changing to cubes, but guys, the rule stays the same. Divide your power by your index. So 3 goes into 6 twice, and 3 goes into 12 4 times with none left over. So there's no root left. All right, 18 is going to have some fun stuff left over. So 3 goes into 10 3 times with 1 left over. Now notice I left some room because there's some Y's and maybe some Z's I'm going to take out. 3 goes into 15 5 times evenly with none left over. And 3 doesn't go into 2, so that has to stay under. Okay, so now we're going to kind of start to put them together. So the numbers and the exponents. So the square root of 16 is 4. That's a perfect square. And then again, I'm going to divide my powers by 2. So that would be x squared and y to the third with 1y left over. 10 is not a square, and it has no squares in it, so it stays put. Nothing can be shot. I'm going to divide all my powers by 2. 2 goes into 3 one time with 1 left over, and 2 does not go into 1, so it stays put. 9 is a perfect square. It's a 3. 2 goes into 2 one time with nothing left, and 2 goes into 10 5 times with nothing left. So I hope you're starting to kind of get the feel for it. 27 is a perfect cube, so the cube root of negative 27 is a negative 3. 3 goes into 6 twice, and 3 goes into 12 4 times. Okay, so now we're going to have to go hunting a little bit. 24, we are square hunting. So let's see, I'm going to do 4 times 6. So that would be 2 with a 6. Notice I left room because I got A's and B's. My index is a 2. So 2 goes into 3 one time with 1 left over. And 2 goes into 2 once with none left over. 54, now up here, when we did 54, we did 27 times 2 because we were hunting cubes. But now I'm hunting squares. So I need a square that goes into 54, and that's going to be 9 times 6. So the square root of 9 is 3. Leave room. There's my 6. Okay, now I'm going to do my powers. 2 goes into 4 twice. 2 goes into 5 twice with 1 left over. And 2 goes into 9 4 times with 1 left over. I think we can skip the rest of these. The goal is just to get a gist. Let's look at number 5 right here. To multiply 2 radicals, you're going to multiply the outside number times the outside number and the inside number times the inside number. They do not have to be like terms to multiply. And then you need to go in here and go square hunting. And when you shoot that 4 and it becomes a 2, you're going to multiply the 2 by the 12 that's already out there. So if I do number 6, outside times outside would be 8. In times in would be 12. I don't care about the 8. I care about the 12. 4 times 3, that's a 2. Times the 8 is 16 root 3. Okay, so I hope this was, I don't know if it was a review or if it was brand new information, but kind of stick with this until this becomes